Hey everybody, it's Gregory Unruh, and we are now in video 4 of our 5-part series on geomimicry. We learned about, in the previous videos, the benefits of geomimicry, but also that geomimicry is at the root of many of our sustainability problems. In this video, we're going to discover another sustainability challenge that is the consequence of our dependence on geomimicry. So we live in and we are products of the biosphere. If you look at the Earth from space, what you notice is the blue-green colors, the blue being liquid water and the green then being life. And that's not an accident. Biology has played a co-evolutionary role in creating life-sustaining conditions on Earth. And you can see the impacts of the biosphere on the atmospheric chemistry in this figure here. This is the Keeling curve, which shows changes in concentrations of CO2 over time since the 1960s, and it's measured on a monthly time scale. Now, what most people see is when they look at this image is they point to that upward trend and the fact that CO2, measurable CO2 in the atmosphere, has been rising over the last several decades, coming primarily from the humans' use of fossil fuel. But what I also think is really interesting, and many people overlook, is if you look on the gray lines around the red line, you can see that they go up and down in these cycles, and that correlates to the annual rise and fall of CO2. It turns out that the concentration of CO2 goes up and down on an annual basis. Now you might ask, well, what causes that? And if you look at the smaller graph below where it says annual cycle, you can see that the decline in CO2 coincides with March and April, ending up around in September. And if you think about that, that coincides with the seasons, and that represents these northern forests, when the northern forests come out of dormancy and come to life. And when they do that, they produce, obviously, huge volumes of green leaves. Now, leaves are really fascinating things. They're little solar panels that trees can produce on demand. But they're actually also created out of thin air. And that's partially because air isn't as thin as we think it is. Our air is actually full with carbon dioxide. And what that happens is the trees breathe in the CO2 and use that captured carbon to create biomass in the forms of leaves and plant growth. And it is such a big event, it has a consequential change on the chemistry of the atmosphere on an annual basis. We can see the northern forests breathing in and breathing out every seasonal cycle. So geology and biology play these dual roles in influencing not only the chemistry of the planet, but also creating a life-friendly planet. So for the first 600 million years of the Earth, we had what was known as a rock vapor atmosphere. It was really, really heavy in carbon dioxide with hydrogen and water vapor. And that's because there were these really active volcanoes spewing lots of carbon dioxide into the atmosphere. Now, as cooling occurred, some of that CO2 began to dissolve into ocean water and then was turned into and subducted away from the surface. So you began removing carbon dioxide from the atmosphere and reducing the greenhouse effect to a level that life could tolerate. And as life spread, then, it had more and more of an impact on the planet and on the atmosphere. Now, this is a figure that's showing the amount of CO2, various estimates of the amount of CO2 in the atmosphere for the last 500 million years, so a very long period of time. And while these graphs are not smooth, there are wiggles up and down, you can see that the overall trend is what I like to call the Great Sequestration, and it's this gradual, over time, reducing the amount of CO2, taking CO2 out of the atmosphere and sequestering it away in the geosphere. And land plants became widespread about 400 million years ago, which in this figure coincides with this sort of rapid decrease in CO2 and the amount of CO2 in the atmosphere. And this downward trend obviously is thanks to this biology, geology working together. As vegetation spread across the planet, biology began then removing large amounts of CO2 from the atmosphere, just like we see when the trees come into bloom in the spring and the amount of CO2 in the atmosphere declines. The same thing was happening on a massive scale as plants began to spread. The Carboniferous period around this time is famous for these giant, vast swamp forests like the one you see in the picture. And those forests were actually, when the plants died, they were often buried, and then they were turned into Carboniferous rocks. Now, Carboniferous means carbon bearing, so they're coal deposits. So the coal deposits are really these buried ancient forests. Plants turned CO2 into biomass, and they were buried and over long periods of time turned into coal. And so this great historic downtrend has helped create an atmosphere, a world that was hospitable for life and hospitable for us as human beings. You can see that carbon dioxide's dropped from about 7,000 parts per million in the Cambrian period to about 500 million parts per million, and then ultimately to around 180 million parts per million in the last 2 million years. And the challenge now for us is that by building our industrial economy on geomimicry, we are now in the process of reversing the Great Sequestration. As we excavate coal mines, we are taking carbon that was sequestered in the atmosphere during the Carboniferous and pumping it back into the atmosphere. We're in the process of recreating this hotter, less hospitable climate, and we're doing so in the blink of a geologic eye. We are reversing trends in tens and hundreds of years of these processes that took millions of years to occur. This is a much shorter version of this measurement of CO2. It's the last 800,000 years, but you can see in the last 10,000 years, the amount of CO2 then has risen dramatically, and that's because we are reversing the Great Sequestration. And the question is, what kind of climate are we creating? Is it going to be less conducive to life? Well, what seems to be certain is it's less conducive to the lifestyles we are accustomed to. The atmosphere is getting less productive. Droughts are getting more frequent. I'm recording this in hurricane season, and we are having the record number of level 4 hurricanes. So we are now beginning to see the effects of us transforming the atmosphere by reversing the Great Sequestration. And geologic history tells us that we should be careful, that halting the reversal of the Great Sequestration should be an important concern of humans at this time. So we're going to discuss how we can reverse the reversal of the Great Sequestration and get that CO2 out of the atmosphere and get back to where the geosphere and the biosphere, get it out of the atmosphere and back into the geosphere where it belongs. We're going to talk about that in our next video.